Okay, we're reviewing some, and basically reviewing how to obtain functions given points on a graph or given information that allows you to put points on a graph. Okay, so let's just say I've got 2 points. Two, 4, and 8, 9. I could find an exponential function. Through the 2 points, I could find a linear function. I could even find a quadratic function. With the vertex at one point, and the other point on the graph. So 3 possible functions I could find here. Okay. And actually 4, because if we're doing a quadratic function, we pick either point as the vertex. So we're going to just see how to do that. And first of all, the linear function. Well, let me give you the form. The exponential function is y equals a times b to the x. The linear function would be either this or this. And there are other forms that we could have, but we usually use this one. In a quadratic function, which when you have vertex at one point, the other point on the graph, we want to use the vertex form. The general form is y equals ax squared plus bx plus c. In the vertex form, which we should know is y equals a times the quantity x minus h squared plus k. Okay, let's start with the linear function. One way to do this is to get 2 simultaneous equations. So if y equals 4 when x equals 2, we can substitute 4 for y, 2 for x. We get 4 equals m times 2 plus b. Substituting the coordinates at this point, we get 9 equals m times 8 plus b. Now that's a literal substitution into this form. Let's go ahead and write that as 2m plus b equals 4. And 8m plus b equals 9. We can treat this as a system of 2 simultaneous equations and solve by elimination. We could also solve by substitution, but I'm going to use elimination. I'm going to do negative 4 times equation 1 which should give me negative 8m minus 4b equals negative 16. Multiplying negative 4 by the 2 gives us this, by the b gives us this. Negative 4 times 4 is negative 16. The second equation remains as it is. It's 8m. That should have been b there. 8m plus b equals 9. We add first equation in the previous step to the second equation. The m's go away and we get negative 3b equals negative 7, so that b equals negative 7/3. We can then plug that into either of the first two equations. So I plug that into first equation. Come around here. I get 2m minus 7/3 equals 4. I multiply both sides by 3 because I don't want to deal with fractions. It's much easier to multiply everything by 3. I get 6m minus 7 equals 12. So make it. We multiply by 3, meaning we multiply both sides by 3, which gives us the solution. M equals 19/6. Okay. That doesn't look right. And that doesn't match slope of the graph. So there's maybe something wrong with what I did here. Careless with the negative signs. It's negative 3b equals negative 7. So b would be plus 7/3. So now correct the solution, and it'll be 5/6. And that could be written a little more clearly. So do a quick correction. Y equals mf plus b becomes y equals 5/6 x plus 7/3. Now we could check this. We could substitute the coordinates of the first point into this and see if we get an identity. So we do that. So I don't have a lot of room here, but I'm going to check my solution over here. Okay. 0.24 means that 4 should equal 5/6 of 2 plus 7/3. Well, 5/6 of 2 is 5/3. And 7/3 is still 7/3. And the arithmetic is straightforward. We get the right result. Now we ordinarily also check 8, 9. If x is 9, this becomes trying to do it in my head and something isn't clicking. So I must have up on the wrong side of the bed this morning. That's pretty simple. We're going to get the 3 there. We're going to get, yeah, okay. I'm trying to get the wrong number. I was right. Okay, so we get 15/3 plus 7/3. I'm sorry. I tried to plug 9 in for x, and I wasn't getting anything that made sense. It's an advantage to write it out, but if I plug 8 in for x, I get 20/3 plus 7/3, which is 27/3, which is 9. So now I'm pretty confident with my solution. Another thing we can do is construct a fundamental triangle here and see if our slope is 5/6. Now there's a formula for slope, yeah, but further you draw the fundamental triangle and label it. And then if you wish, use the formula to verify it and use the formula to understand how it matches the fundamental triangle. So that's going to give you greater. Let's pretend that triangle, let's pretend that hypotenuse is straight and that it actually goes through this point. Okay. So what we get is the run equals 8 minus 2, which is 6. The rise equals 9 minus 4, which is 5. So the slope is rise over run, which is 5/6. So I put 5/6 here. If I ask you on a problem to construct the fundamental triangle, I want you to do this. If I ask you to find the equation between these 2 points using 2 simultaneous equations, then this is what you do. If I ask you to do it using the slope and the intercept, I want to see the fundamental triangle. And then you can use definition of slope and so forth, which gives you the point slope form of the equation, as you use that. If I don't say how to do it, you can use anything. Okay, so we want to find an exponential function through these 2 points. An exponential function through 2, 4, and 8, 9. Y equals AB to the X. So using the point 2, 4, we get 4 equals A, B to the second. Using the point 8, 9, we get 9 equals A, B to the fourth. Here's our system. We can't solve this system by elimination. These are not linear equations. Neither of these is a linear equation because you got, among others, you got power of B. Okay, power other than 1. So we solve equation 1 for A. We could solve it for B, it would get more complicated expressions. Probably easiest to solve equation 1 for A. Then we get A equals 4 over B squared. Substitute this into equation 2. We get 9 equals 4 over B squared times B to the 4th. We've replaced A here with 4 over B squared, and we can see that. So that we multiply both sides by b squared. Well, actually, I'm not going to do that yet. We're going to simplify. Using the rule for exponents, we're going to get 9 equals 4 b squared. Solve for b. And we're going to get, I'll do it in 2 steps. We get b squared equals 9 over 4, dividing both sides by 4. So that b equals plus or minus the square root of 9/4, which is plus or minus 3/2. Remember, when we solve b squared equals something, one solution is the square root of that thing, which would be the 3/2. But also, if you square negative 3/2, you're going to still get 9/4. So you have the 2 solutions. Okay. Now, for an exponential function, b can't be negative. Okay. So we reject negative 3/2, conclude that b equals 3/2. Now we plug this into, let's say, actually want to plug it into one of the original equations, and it was not watching where I was going. So let's see if we can plug it into the first equation. And what do we get? We get 4 equals a times 3/2 squared, which is 4 equals a times 9/4. And we easily solve that for a. We get a equals 16 over 9. So now our function is y equals 16/9 times 3/2 to dx. Or y equals 16/9 times 1.5 to the x. There are things we can do with this exponential function. And I might just go ahead and do, I'm going to do at least this much. Growth rate is just 0.5 or 0.5. The growth factor is 1.5. There's a doubling time here. Well, I say y doubles in time t dog. Where y doubles when you plug in t dub. Okay, now there's a more detailed way to look at that. And I should probably write it out. I was going to shortcut it. More pressed for time due to the snow day on the second to last day of classes. Y2 equals 2 times Y1, then Y is double. So Y2 equals 2 times Y1. If Y1 equals 16/9 times 1.5 to the x, and Y2 equals 2 times 16/9 times 1.5 to the x. Also, Y2 is going to be 1.5. 16/9 times 1.5 times x plus t double. Because when you go from x to x plus t dub, you have the doubling time. Okay, so strike up. You have your exponential function here. Here's x. Here's y1. Here's 2y1, twice as big as y1, twice as far from the x-axis as y1. And the x here is x plus t dub. T dub is the time between this and this. So you have this set of equations. Then y2 equals 2y1. Y2 is this, y1 is this. Y2 is this. Y1 is this. So 2y1 is 2 times this, which is here. So there's the equation we can solve. We can divide both sides by 16/9 or multiply by 9/16. In the 16/9 times 9/16 is 1, we end up with 1.5 to the x plus t dub equals 2 times 1.5 to the x. So illustrating a little bit about rules of exponents. If you're not real familiar with rules of exponents, it might not occur to you. Well, the next step might not occur to you. Let's just write out the previous step here. Okay. 1.5 to the x plus t dub is 1.5 to the x times 1.5 to t dub. If we divide both sides by 1.5 to the x, it goes away. You get 1.5 to the t dub equals 2. Solve for t dub. We change this to log. There it is. Now you plug that into your calculator. It's a log of 2 divided by the log of 1.5. And which is about maybe, I'm just making a wild guess. It's not a wild guess. I know that 1.5 squared is 2¼ so the result is going to be less than 2, and that I made a bad estimate. I was confusing my numbers. And I sometimes do. Okay, so let me change that to about 1.8. Well, that's my best wild guess on this one. Now, that takes us a little ways from our original purpose, but since we have an exponential function here, I was able to illustrate growth rate, growth factor, things they're supposed to know, doubling time, and how to solve for doubling time. Now, there's an easy way to solve for doubling time that you probably used when you did the homework. Okay, because what happens is, in every case, all this other stuff goes away, and you just find when the 1.5 to the t dub equals 2. In other words, what time t dub causes the 1.5 to double, because if the 1.5 doubles, then where did I write the equation of the function? I know I wrote it out. I think I wrote it out. Yeah, there it is. Should have put a big box around it so I can see it. There's our function. Doesn't matter what's in front of this. This is what's going to double. If this doubles, the whole thing doubles. So you don't necessarily have to go through all these steps, but it's worth looking at these steps and understanding them, because you might need similar steps to solve other equations. Okay. So if you're just trying to find the doubling time, you're safe saying, well, the only way this is going to double is if this doubles. Okay. And for this to double, you just have to have 1.5 to the doubling time equals 2. Okay. And this is actually a more general proof. It's actually proof that that works, and you can use it. Okay. So whatever your favorite explanation is, I don't expect you to have to go through all this, but if you want to impress me, go ahead. Okay. All right. Well, again, that took us a little ways from our original purpose of review, but there it is. Now we started. We started with 2 points, 2, 4, and 8, 9. We used the form y equals mx plus b to get two simultaneous linear equations. One where we substituted 2, 4 for x and y. Where's y equals mx plus b? Yeah. Well, yeah. Okay. We substituted 2 for x, 4 for y. We got this equation. We substituted 8 for x, 9 for y, and we got this equation. And then we went ahead and used elimination to solve this equation. So we illustrated the process of elimination. Now that's a recent process people seem to be doing really well with. Okay, so I'm not going to say too much more about elimination. I will also though mention that we could have used an augmented matrix. Okay, you could have taken the matrix 2, 1, 4, 8, 1, 9, and reduced it. Okay. I'll probably come back and do that, but I don't want to take us too far away from finding the quadratic function. Okay. So what we want to do now is find a quadratic function with the vertex. Okay. So I want everybody to vote. And if the vote is split, I'll have to flip a coin because we have an even number of people here. Okay. Left or right? Thumbs to the left or thumbs to the right? Let's say left. Okay. So we're going to use this point as the vertex. Okay. If we use this point as vertex, it'd be completely different. I might even do both. We'll see. Okay. So what this means is we want to find a quadratic function with the vertex at the point 2, 4. With the graph passing through 8, 9. Okay. Well, we use the form. Y equals A times quantity x minus h squared plus k. Form I've written here. We don't want to use this form because you have 3 parameters here, A, B, and C, and you don't know any of them. You only have 2 points, it would give you 2 equations, but you have 3 unknowns. If you have 3 unknowns with 2 equations, you're going to have to get tricky to solve it. You're going to have to use symmetry, is what it amounts to. And it's kind of challenging to figure out how to use symmetry in that case. With the vertex form, symmetry is already built in. And what do we see here? How many parameters do you have? Well, you have A, H, and K, right? That's 3 parameters, but you know one of them. You know A? From this information, vertex is a 2, 4, passing through 8, 9. You don't know A. Do you know H? Well, yeah, H, K, these are the coordinates of the vertex. Okay. So now we know the coordinates of the vertex, and we only have to substitute the coordinates of the second point to solve for A. Okay, Let's see how that works. Now, we definitely want to see this in the context of a transformation of the basic toolkit squaring function. Okay, because that's all this is. This is a f of x minus h plus k. But f of x is the x squared function. Okay, so I'm going to make a little note here. This is that is the vertex form. So it's not like you have to memorize the vertex form, although it's fairly easy to memorize. You want to see it in this context, because any transformation with a vertical stretch and a horizontal and vertical shift has this form for some function. Okay, whatever your toolkit function is. If the toolkit function happens to be the squaring function, then you get a general form with a very important quadratic function. Okay. Now, if it's in this form, you can put it into this form. If it's in this form, you can put it into this form. We're probably going to talk about that too, but let's go ahead and get the equation. So we know h equals 2 and k equals 4. The graph passes through the 0.89. So from that, x equals 8 and y equals 9. Now, in an ordinary class, I'd ask you to go ahead and write down the equation you get. But you can look at this and see that if we can replace x and y with numbers, which we just said we can do, and h and k with numbers, the only symbol left is a. And you have an equation you can easily solve for a. So we get nine equals a times x is 8 minus h is 2 plus k, which is 4. And this, of course, is squared. So there we substituted these 4 values. We do a little arithmetic. 8 minus 2 is 6. 6 squared is 36. So what's a? Well, we're going to subtract 4 from both sides. We're going to get 36. A equals 5. A equals 536. And if I've done everything right, this is the equation of the function. Now, let's check. What if x equals 2? We're checking the 0.24. We're going to substitute 2 in 4. Well, if x equals 2, x minus 2 is 0. So this whole term is 0, and we get y equals 4. So we get to 0.24 on the graph. I don't have room to write all that out. And then if x equals 8, y equals 5/36 of 8 minus 2 squared plus 4. And I don't have room to write out the arithmetic, but 8 minus 2 is 6. Square that, we get 36. So we have 36 divided by 36, leaving us 5. Add 4 to that, and we get 9. So we do have the 0.89. It lies on the graph, and we can put a big check mark on it. In general form, the equation is what? Well, we find the general form. We have y equals 5/36 times x minus 2 squared plus 4. So y equals 5/36 times x squared minus 4x plus 4 plus 4. Y equals 5/36 x squared. 4 times 5/36 is 5/9. So we have minus 5/9 x. And 5/36 of 4 is just 5/9. So it's going to be 4 and 5/9. And 4 and 5/9 is 41/9. And we can change these to decimal form, but we end up rounding off to be an approximation. These are the exact coefficients, if I've done this correctly. Okay, so we could check it out. Again, we could let x equal 2 and see what we get. Hopefully what we get is 4. Okay, we can let x equal 8 and do all this, and hopefully we get 9. Okay, I'm not going to go through the details of that, but we could. So I'm not absolutely sure this is a correct equation. Let's ask if it makes sense. 41/9 is a little more than 4. If we go back to our original graph, it had the point 2, 4. It had the point 8, 9. This is supposed to be the vertex. So if I draw a quadratic function with this vertex by the symmetry, here's your axis of symmetry. So x equals 2. This point is 6 units to the right and 7 units up from the vertex. So we'd have to have a point 6 units to the left and 7 units up, would probably be about here. So now let's draw a nice parabola through these points. And of course, anytime I label something, I know something is going to go through my label. Okay, so this is the point. This is where y equals 4. X equals 2, y equals 4. 41/9 is a little more than 4. If y equals 0, well, what is the y-intercept? It's 41/9, right? Because y-intercept occurs when x equals 0. All these x's are 0, so we just get 41/9. That's 4 5/9, a little more than 4.5. Okay. And it's actually like 4.55. Does that make sense? Well, if this is 4, this is a little bit higher, right? That makes perfectly good sense. So if you can sketch the graph, and the graph's a little asymmetric, it should have gone up a little faster here. That 5/9 should have been just maybe a little higher, but it's a hand sketch graph. It's totally plausible that that's correct. Again, we can check it. We can plug in 2 and see if we get 4. We can plug in 8, see if we get 9. Let's look at one more thing. Let's do the quadratic formula. Zeros of y are at negative 5/36, plus or minus the square root of, oh, it's not 5/36, it's 5/9. 5/9 squared minus 4 times 5/36 times 41/9. Don't worry, we're not actually going to do all the arithmetic, but we're going to do some of it. Okay. That's 20 times 41, which is 820. 9 times 36 is 81 times 4, which is 424. So we have 820 over 424 there. Now, 820 over 424 is more than 1, right? So the numerator here is bigger than the denominator, is what I'm trying to get at. And it's a negative, right? What's this thing? It's less than 1, isn't it? 5/9 times 5/9 is 25/81. Well, 5/9 is less than 1. If you multiply a number less than 1, another number less than 1 is going to get smaller. So if you multiply 5/9 times 5/9, it's going to get smaller. It's going to be less than 1. It's going to be closer to 1/3 or 1/4. Okay. So it'd be subtracting a bigger number from a smaller number. We'd have a negative number under the discriminant. Okay. So it's negative in here, so there are no x-intercepts. What else can we determine looking at the quadratic formula? Well, look at this. What did I just circle? I circled the x-coordinate of the axis of symmetry, right? I throw away the discriminant, and we have the axis of symmetry. So the axis of symmetry is x equals negative 5/9 over 2 times 5/36, which is negative 5/9 over 10/36, which is, and it's negative of negative 5/9. So I'm just going to take the two negatives here, make it positive. And that's going to be 5/9 times 36 over 10, which is 2. 9 goes into 36 4 times, 5 goes into 10 twice, so we have 4 over 2, which is 2, okay? This tells us the axis symmetry is this, and this is the same as this. We already know because we chose this as the vertex. Make sense? So there's a whole full circle, a whole lot of stuff about quadratic functions, how to graph quadratic functions, and so forth. Okay. Now let's just look at what would have happened if we had chosen the other point for the vertex. Okay. Well, if we look at what we did over here, we substituted we get abbreviating what we did over here. We identify H and K as the coordinates of the vertex, and they're 8 and 9. We're still going to have the same form of the function, and we're still going to be able to solve for A very easily. Form is AF of X minus H plus K f of X equal X squared. Thus, Y equals what? It's A. What's F of X minus H? Well, replace X by X minus H. Get F of X minus H. Replacing X by X minus H, we have to replace this X. Make sure you remember that. You're going to have to do some composites in the exam, okay? A times quantity X minus A squared plus A. In this case, Y equals A times X minus H squared plus 9. Second point is 2, 4, the one we used previously for the vertex. Q equals A times X minus A squared plus 9. It's not X minus H, and it's not 2. Y is 4, X is 2. So we get 4 equals 36A plus 9. Yeah. Notice before we got 9 equals 36A plus 4. So we've got a different solution this time. Well, what we get here is subtract the 9, we get -5. A is -5 over 36. So our equation is Y equals -5/36 times X minus 8 squared plus 9. If we were to expand this, we get -5/36x. Then we would get plus 64 times 5 over 36. 64 times 5 is 320. 36. 64. Finding the x term. 16. So it'd be 80 over 36x. It would be, and minus this plus this. We can reduce this fraction to 20 over 9. This fraction reduces to 80 over 9. So we get all this. Okay. In any case, we notice, should be x squared here. We notice that the coefficient of x squared is negative. What does that mean for a quadratic function? Now, that's one thing you want to focus on. The rest of this is just arithmetic. I just expanded this and probably made a mistake somewhere. But maybe not, because I'm getting a y-intercept of 1/9. If I sketch a graph, vertex here, the other point here, and here's our axis of symmetry. And I have another point here. So if I draw a parabola through here and through here, it looks like it comes pretty close to the origin. It looks like the way I just drew it, the y-intercept is just a tad bit below the origin, just a fraction below 0. And this says that it ought to be just above 0. So we can, I don't want to go into any more detail here. But I think that might be the function. If I find the coordinates of the axis of symmetry, it's going to be the negative of this over this. And that's going to give me 29 over 2 times this. Yeah, we're going to get 8. Okay. If you plug these numbers in to the quadratic formula, we're going to get 8, and we're not going to get a negative under the radical, which shows that there are 2 x-intercepts, which there have to be. Because if the vertex is up here and it goes through a point down here, it is opening downward. So we can see all the aspects of this function. I wouldn't expect you to do this whole analysis. I just say do a complete analysis of this function, okay? I gave you some hints. I gave you some steps, and I give you easier numbers. Okay. I probably have it come out with whole numbers rather than a bunch of off-the-wall fractions. Does that make sense? So you should theoretically be able to do this, but at least make sure you understand how to graph a quadratic function. Okay. And you should be able to use a given form to find the equation of any of these functions. Okay. And that was the main thing I wanted to talk about. Okay. It all starts with 2 points on a graph. We have these points. I've written that pretty small. we can get quadratic function. This vertex, not the y-intercept won't be that low. That's just the way I happen to draw the points. We get a quadratic function. With that axis of symmetry, we get a quadratic function. With this axis of symmetry, we can get a linear function. Different colors. Ouch. Okay. To depict our functions. There's an exponential function.